visible or not. Uh, okay. uh, All right. So I hope you can see the screen. So these are the questions from week 2 assignments from previous iteration of this course, and it's mostly related to set theory principles, and I'll be solving the questions from the previous year's assignments, and this year's assignments are for you to solve. Okay, so I'll get started. Uh, Coming to question number 1. So you have a set A 1576. So what is the number of non-empty subsets of A? So what they mean to ask is, so let us try to understand what they are asking in the question. So what are meant by subsets of A? So basically subsets of A could be, so A is 1576. Some examples of subset would be, example of subsets would be 1 5 or 5 6 or 1 7 6 or 1 7, etc. So these are the subsets of A. What they are asking is how many such subsets of A do does exist, and we cannot consider a non we have to consider non-empty subsets. We cannot consider an empty subset. So an empty subset would be just a blank with no elements in it. So this is also a subset, but we don't want to count it. Empty subset. So how to solve this problem is like this. So you take A, you have four elements, 1, 5, 7, and 6. And now for each element in A, you decide whether to uh, take it in the subset or not. So for every element, we have to make two decisions, whether to include it in the subset, yes, or no, whether not to include it in the subset. So we have uh, two decisions for all of the four elements present in the set. So where y is someone saying anything? Uh, can you just say a bit loud? Uh, was someone saying anything? Okay, so let us continue. So Y stands for yes, include in subset, and N stands for no, don't include. So for every element in the set A, we have two decisions. So we have therefore total possible subsets would basically be 2 to the power cardinality of A, that is 2 to the power 4 in this case. Now this also includes the empty subset. which is the there is no element. That is, if we take this combination of uh, no, 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 and no. So if we take this combination, we get the empty subset. So we cannot count the empty subset because the question asks only for non-empty subset. So therefore, uh, total non-empty subsets equal to 2 to the power cardinality of a minus 1, that is 2 to the power 4 minus 1, which is 15. So the right answer is option B, which is 15 for this question. Okay, so someone had asked that you are not able to see the questions while I am solving it. So I'll be pasting this question in the chat window. So you can refer to the questions as while I am solving it. So just give me a minute. I'll just copy paste. So this is question one. You can refer to the chat window to see the question while I solve it. And if you have any doubt regarding this question, you can ask me now or even at the end as well. So if no one has a question, we can move on to question number two. So I'll paste question number two before we solve it. Okay, so this is I have uh, pasted question number two. Uh, so let us try to solve it. So the question two says that we have a set A which consists of two elements. So let us look at the two elements. So this is one element and it's, this is another element. So the set A consists of two elements. So we have to answer the following. So you are given two statements. One, that phi, that is the null set, is it belongs to A or not. So A is not empty. So here A is not empty. A has two elements. A has two elements, which implies that statement 1 is false. Now, the second come to the second statement, which says that phi is a subset of A. So this is always true because phi is a subset of all set. So always true as phi is a subset of any set. So statement 1 is false and statement 2 is true. Therefore, option C is the correct answer for this question. I hope that is clear. If you have a doubt, you can ask me now. Uh, all right. So we'll move on to question number three. So uh, before I solve, I'll paste the question. Okay. So this is question number 3. So what question number 3 says that in a class 50% of the students uh, to play chess, 40% like to play carom, and 10% like to play both chess and carom. What percentage of the class likes neither chess nor carom? So to solve this question, so we'll first draw the set of the class. Let us say this rectangle represents the entire class. So we'll draw a set. This red circle represents the set of students who like to play chess, and it is 50%. And the green circle represents the set uh, who like to play carom, and 10% lies in the overlap between chess and carom. That is, they like both chess and carom. So, what percentage of class likes neither chess nor carom? So, I'll first denote the regions. So, okay, the green is for carom. So, CA carom, EH chess, and the entire class CL is the total class. So what we have been asked to find is which portion of the class likes neither chess nor carom. So if you look at the figure, what they are asking us is to find this region that is outside both the circles. So the dotted region, so what is the size of the dotted region is the question they are asking us. So how to find what is in the dotted region? So basically, let there be X student. Let the class consist of X students. So what is the number of students? What is the number of students that like either chess or carom? So let us denote it by y, say. So basically, our answer is that who neither likes chess nor carom would be basically the total number of students minus y, which is the number of students that like either chess or carom. So we'll have to basically find y. So y is, if we take the union of two sets, what is union? So is the cardinality is basically chess union carom. So chess is your in red and carom is in green. So y, so the cardinality basically wait. So we want to find the cardinality of this set. So y is nothing but cardinality of chess plus cardinality of carom minus the cardinality of S intersection cam. So that is nothing but chess is 50% of the class. So that would be 0.5x. Carom is 40% of the class. That is 0.4x. And chess intersection carom is 10%. That is 10% like to play both chess and carom. That is 0.1x. So this turns out to be 0.8x. So now x plus y is basically x minus 0.8x, that is 0.2x, which is 20%. So the answer to this question is what percentage of the class likes neither chess nor carom is 20%. So 20% is the size, 20% of the class is denoted by this dotted region. All right. So I hope this is clear. Let us move on to the next question. Coming to question number 4. So let me paste question number 4 first. So this is question number 4, and we have been asked that let A and B be two sets in a universe. Which of the following is or equal to A minus B? So again, let me first draw the set. This is the universe. We call it U. Let this set be A, and let this be B. So which of the following is or equal to A minus B? So before solving it, let us denote each there are basically four regions in this diagram. So let us first identify the four regions. So first is this dotted region. We call this region 1. Next comes the region that's within A but not overlapping with B. So this red region, we call this region 2. Next comes region 3, which is the region that lies in B but does not overlap with A. So this is region 3. And finally, we have region 4. We'll denote it by this orange color. So we have four regions. So can anyone tell me which is A minus B in this figure? Can anyone in the comment in the chat which region is A minus B? Which region 1, 2, 3, 4, and what's their combination denotes the region A minus B? Okay, so yeah, both of you are right. It's region 2. So we have to basically find out how to express region 2. So region 2 is A minus B. So let me write it, region 2. Now, out of this four options, which of them represents region 2? So let us check first. So A, if we say A, it is A in intersection B complement. So B complement is basically all the region that is outside of D. So it is region 1 plus region 2. So what is B complement? Let me write it here. Uh, B complement is 1 plus 2, and A is 2 plus 4. So A intersection B complement would be the common element, that is 2. So option A is correct. Now let us check all the other options. What is A complement? So coming to option B, this is, let's say, for option A. If we check B, so A complement would be anything outside of A, that is 1 plus 3, and B is 4 plus 3. So A complement union B would basically be 1 plus 3 plus 4, and the whole complement of it would be, so we are left with only region 2. So you see, A complement union B complement B whole complement would also leave us with region 2. So option B is also correct for this question. If we look at option, let's say C, again A complement is 1 plus 3, and B is 4 plus 3. So A complement intersection B would be 3, but this is not what we want. So option C is not correct. And if we check option D, it is A union. Okay, so let me write it first. A is 2 plus 4. B complement is 1 plus 2, and A union B complement would therefore be 1, 2, 4, and if we take the whole complement of it, we'll get 3. So which is again not correct. So the right answers are option A and B. So you can expand this again using De Morgan's law as well. So A complement union B whole complement can be written as A intersection B complement, which is the same as the previous one. So A and B are basically the same thing, and D can also be written as A complement intersection B, which is again the same as C. That's why we are getting the same result for C and D and same results for A and B. So you can check that way as well. So this is question number 4. So if you have any doubt, you can ask, or I'll proceed to the next question. Okay.
Hello.
Yeah, go ahead.
Sir, what we will do in tomorrow's problem solving session?
Uh, it, Tomorrow's problem solving session will discuss set theories and different. He will discuss different sets of problems for related to set theory.
Okay, so related to week two.
Yeah, week 2.
Oh, okay, sir. Thank you, sir.
Yeah. Okay. Let us move on to question number 5. So again, before going to question number 5, I'll paste it over here. So we have two sets A and B. Which of the following is equal to the symmetric difference of the two sets A, symmetric difference B? So basically, what we'll have to do is this. So again, I'll draw the set diagram, Venn diagram basically. So this is the universe, and you have in the universe you have two sets A and B. So what is meant by the symmetric difference is, okay, this is the universe. Symmetric difference is the region that is contained exclusively in A or exclusively in B, but not in both. So in the diagram, again, we'll draw the region. So one is the region outside both the sets. Uh, Two is the region that is uh, in A but not overlapping with B. Three is the region that is in B but not overlapping with A. And finally, this 4 is the region where that's overlapping. So what symmetric difference, is basically we have to find out 2 plus 3. So this region 2 plus 3 is basically the symmetric difference of the two sets. So now which of the following are correct? So if you see the first one, A union B, so A union B would be, so let me write it. Okay, I'll write it here. A. A union B would be 2 plus 4 plus 3, and A intersection B would be 4. So A union B minus A intersection B would be 2 plus 3. So option A is correct answer for this question. If we see option B, A minus B, that is region 2, and B minus A is region 3. Therefore, A minus B union B minus A would be 2 plus 3. So again, option B is correct. Now let us check option C. Option C, we can rewrite option C. So option C is saying like this: A minus B whole complement union B minus A whole complement and complement of that. So if we apply De Morgan's law, we'll get A minus B intersection B minus A. So A minus B is 2 and B minus A is 3. So there is no intersection. So it's a null set, empty. So option C is not correct. Option D, again applying De Morgan's theorem, we can write it as A minus B union B minus A. So that is same as option B. So therefore option D is also correct. So the right answers are A, B and D. So these are the right answers for this question. I hope that is clear. Okay, let us move on to the next question. Coming to question number 6, I'll paste it here. So question number 6 is that you have this universal set X. X is a set of natural numbers between 19 and 12 containing both 19 and 12. 12 and 19. So n is the set of natural numbers. And if S is 12, 13, 14, 15 and C is 14, 16, 18, 19. So what is S minus C complement? So first let me write down the sets. So let's write down this. What is U? The universal set in 12, 13, 14, 15, 16, 17, 18, 19. What is S? 15. And C is 14, 16, 18, 19. So now so it's a pretty straightforward question. So what is S minus C? S minus C are all the elements in S that are not present in C. So what is 12 is exclusive to S, 13 is exclusive to S, 14 is present in C, so we have to ignore 14, and 15 is also exclusively in S. So 12, 13, 15 is S minus C. So what is S minus C whole complement would be basically what is the no, elements in the universal set other than that is present in S minus C. So leaving 12, 13, 15, what else is present? So we have 14, we have 16, we have 17, we have 18, we have 19. So this is the correct answer. So option A is the correct answer for this question. Okay. Um, Moving on to question number 7. So we have I'll paste question number 7. Just so we have a universal set and two sets A and B. Given the cardinality, the universal set has 60 elements, A has 20 elements, B has 25 elements, and A intersection B has 5 elements. So find the cardinality of A complement intersection B complement. So basically, uh, using De Morgan's law, again we can write A complement intersection B complement is A union B full complement. This is from De Morgan's law. De Morgan's law. Now, cardinality of A complement intersection B complement is same as cardinality of A union B full complement, which is nothing but complement of the universal set minus complement of A union B. So now A union B complement can be written as A complement plus uh, uh, cardinality of A union B is written as cardinality of A plus cardinality of B minus cardinality of A intersection B. So that gives us from here we get A complement intersection B complement, the cardinality of which is given by cardinality of U minus cardinality of A minus cardinality of B plus cardinality of A intersection B. So these values are, I think, given. So it is 60, A is 20, B is 25, and A intersection B is 5. So if you do the maths, it comes out to be a minus 40, it comes out to be 20. So the right answer for this question is option C, 20. All right. So we'll move on to question number 8, and I'll paste question number 8 in this. So you have a set A which consists of 4 elements. So let me mark the element. So you have states of India. This is one element. Another element that contains a set which has only two states, Karnataka and Kerala. Next, we have Gujarat and we have Punjab. Now, which of the following will be an element in the power set of A? So, power set of A is basically uh, all subsets of A. So, that is the first question that we solved today. So, finding all the possible set of all subsets of A. So what we did in question 1 was finding the cardinality of the power set of A. So here we considered the power set of A basically means all the possible subsets of A. So which of the following will be an element in the power set of A? So you have first Karnataka. So Karnataka, if you see, it comes within this set. In this set, so let me call it, let me 1, 2, 3, 4. So you have 4 elements. So Karnataka is a subset of 2, but it does not exist as a singleton inside A. Therefore, it won't appear as a singleton in the power set of A. So Karnataka is not a right answer. Same applies to Kerala because it also comes combined in this element 2 as a set of Karnataka and Kerala and does not exist as a singleton. But Punjab and Gujarat exist as singletons, and therefore they can exist in the power set of A. So one another example that could have been in the power set of A would be like this. You have Karnataka and Kerala. So this element combined, and let's say you have Punjab. So if you have a set like this, so this belongs to the power set of A. But Karnataka and Kerala cannot exist as singletons. I hope that is clear. Uh, all right. So we'll move on to question number 9. Yeah, I'll paste question number 9. So in question number 9, you have A complement union B whole complement and A complement intersection B are disjoint sets. What are disjoint sets? So this means that A complement union B whole complement, this set intersection with the other set A complement intersection B, this should be a null set. So there is disjoint set means that there is no overlapping elements between the two sets. So if we look at this first set by De Morgan's law, we can write it as A intersection B complement, right? So, and we have, on the other hand, we have intersection of A complement intersection B. So if we look at this set, so I'll draw the set B. So what is A intersection B complement? Again, let me write the numbers 1, 2, 4, 3. So this part A intersection B complement. B complement is anything that is outside of B, and A intersection B complement is region 2, and A complement intersection B would basically be the any region outside of A and contained within B, that is region 3. So you can see that 2 and 3 are disjoint uh, sets, and therefore their intersection is equal to 5. So this question answer is true, that A complement union B whole complement and A in complement intersection B, they are disjoint sets. Uh, is this question clear to everyone? I All right. So let us move on to the final question. That's question number 10. So I have pasted question number 10. So In question number 10, so we have a set S which has 7 elements and a set T which has 9 elements. Let set T denote the symmetric difference between S and P. So find the cardinality of the set S intersection of P symmetric difference with T. So I'll again draw the set diagram. Okay, so we have S, we have P. Again, let me name the regions. So you have 1, 2, 3, and 4. So where does T lie? So T is in the symmetric difference of T is equal to S symmetric difference with P. Sorry. So this is basically all the elements that are in exclusively in S or exclusively in P, but not in both. So this is basically 2 plus 3. Now, what is, uh, let us look at the next one. What is the symmetric difference of P and T? If you look at that, so it is basically all the elements. Wait, let me write it like this. So P is basically um, 3 plus 4 and S is basically 2 plus 4. Okay. So now P symmetric difference with T is basically all the elements of P and T that are either exclusively in T or exclusively in P but not in the both. So we basically take the union and uh, subtract the intersection part. So the intersection part between P and T is this region 3. So it will take the union. So it's 2 plus 4. So we in remove the intersection region while taking the symmetric difference. And what is S intersection of P symmetric difference with T is basically, if you see P, the symmetric difference between P and T and S are basically two identical sets. Therefore, the S intersection with the symmetric difference would be the same set. So the entire set overlaps. So that is equal to S. So the cardinality of this is nothing but the cardinality of S, which is 7. So option B is the correct answer for this question. I hope that is clear to everyone. So these were the questions from week 2 that I discussed. So I hope this will help you in solving this year's assignment. If you have any other doubts related to any other questions that I discussed so far, you can ask. Um, all right, then I don't think anyone has a questions this session. If not, you can start leaving if you don't have any questions to ask as well. Uh, uh, okay, thank you everyone for joining. Okay, someone has a question. Okay. Yeah, thank you. Thank you for everyone for taking the time to join this session. I hope I wish you all the best for this course, and I hope we'll meet again next week. Yeah, the PPT will be shared in the course web page. You can the I'll show you where you can find the PPT. Just I have pasted the screenshot of where the PPT and the recordings can be found.